Okay, let us start our lecture today. Anyone can see this one? Hello? Anyone can see?
Yes, sir. Bisa, Pak. Bisa, Pak.
Okay, yeah, good. Okay, today's lecture is about Coulomb's law. Yeah, so yesterday lecture we discussed about Newton's law of motions, in which a things called particle is characterized by its mass, called inertial mass. So basically, this mass is internal or intrinsic properties of so-called elementary particles. So the elementary particle basically is building blocks of our universe. Okay. So another property that also belongs to things of particle is called charge, electric charge. So yesterday we have discussed that this M should be positive in Newton's law of motions, but in this case, electric charge could also negative and also positive. Yeah, we could also say that this Q equal to 0. Let's see. Okay, let's see. This Q also, we could have Q equals to 0. But this is called neutral in the context of Coulomb's law. Yeah? Okay, I mean this neutral particle doesn't obey Coulomb's law in this case. Only Newton's law. So basically, Newton's law claims that Newton's laws of motion claims that every particle should have positive mass. Okay. So this electric charge and also mass, as I said before, these are the intrinsic properties of particles. What it means that these particles or these elementary particles can be distinguished by its mass, by their mass, and also their charge. For example, we have electron. Yeah, electron is minus E. E is the electric charge unit. It equals to 1.602 times 10 to the minus 19 Coulomb. So the unit of the charge, we call it Coulomb. Coulomb, okay. And also we have also proton, okay. Proton, the Q, the charge, the electric charge, equal to plus E, okay. So they have different electric charges, okay. And we also know that this electron have mass ME, sorry, is 9.11 times 10 to the minus 31 kilograms. And this MP is 1.60719, 10 to the minus 27 kilograms. The mass of the photon, or the mass of the proton, okay? So as we have seen that these properties distinguish between them. So electrons have different charges compared to the proton, and also the electron have mass different from the proton. Okay, so that's why we call it this mass, and also electric charge can be used to distinguish between particles. Okay, but these properties cannot be applied to, for example, in macroscopic case. For example, in human, for example. In human, how we can distinguish, for example, between two persons, for example. Can I have your opinion? How we can distinguish between two persons, so one person to another person? How we can distinguish?
DNA, sir.
DNA, yeah, it's very precise answer. For example, you can say for the name, okay? The name, for example, my name is Bobby, yeah. Bobby, there are also a person names Bobby, okay, beside me. Okay, so the name somehow we cannot distinguish in general human. For example, fingerprint, yeah, fingerprint is unique. Each person have a unique fingerprint, yeah, as far as I know. Yeah. It's also, this is also the intrinsic property, yeah, that we can distinguish between one person to another person, fingerprint. And your friend said, for example, DNA, yeah, DNA. It's microscopic properties, of course, yeah. But for example, with your friend, we could also distinguish between them as if you can see from, for example, the color of the hair, for example, only 2%. Or the shape of your face, of their face, the color of their skin. That's the intrinsic, the properties that belongs to the person. That is, we can distinguish between them. Okay. For example, if you want, if you apply a passport, the questionnaire in the passport form, it doesn't. I mean, on the form, in the form, they don't ask your DNA or how your fingerprint. Okay? So they only ask about the color of your hair, the shape of your face, for example. You have mustache, for example, glass, yeah. The color of the eye, for example, retina, and etc. Okay, that's the intrinsic properties, for example, for a human. Okay. So for elementary particles, we can distinguish between them using its mass, yeah, by its mass, and also its electric charge. So basically, mass and the electric charge is the fundamental properties of the building blocks of our universe. Okay, so yesterday we have discussed about Newton's law of motions, yeah, in which the dynamics of the particle, so the particle, if it obeys the Newton's law of motion, the particle should have mass, positive mass. What about if the particle has electric charge? So there is also another so-called interaction. Yeah. Interaction means at least two particles. So interaction, it means that in this case, electric interaction. So between Q, for example, two charges, capital Q and Q, okay? So for example, they have distance between them is R, okay? So the interaction between them, we call it the intensity of interaction, yeah, according to Coulomb's law, yeah, they it proportional to the charges of the particle, capital Q and Q, but they are proportional to the inverse of the square of the distance, okay? So because this intensity of interaction, we could define that this is basically the force, yeah? This F, we call it F here, is the F equals to K, Q, capital Q, times Q over R squared. This K is the constant, the constant over 4 pi epsilon 0. Approximately this quantity, yeah, is 9 times 10 to 9 newtons meter square over c squared. Okay. Okay, is there any question? Any question? Okay, so far so good. So there is also a question. We see that from this expression, this F equals to K capital Q, Q times Q over R squared. But somehow we cannot see directly how is the charge related to its mass of a particle. Do you have any opinion about this? Dia, Dalila. Dia.
Yes, sir. I don't have any.
Okay, your sound is okay. Can you hello? Yes, Dia. Hello. Can you answer the question? This question. What is about your opinion about? Does an electric charge particle have mass? Have a mass?
No, sir.
Okay. Who is answering the question? Sorry. Hello. Who is answering? Who was answering the question?
Me, sir. Davin.
Okay, Davin. Okay, thank you, Davin. Anyone? So this interaction doesn't involve the the mass of the particle, okay? So we could raise a question, does an electric charge particle have a mass?
Hello, sir.
Why?
But on the force, as in Newton's law, we have mass and acceleration. So it probably should have mass.
Sorry, can you repeat your answer again?
Because because in Newton's first law, it is F equals ma. So can substitute the F to ma. And if the mass is 0, the A should not possible. Infinite.
Okay, yeah. Thank you, Lilo. Yeah, that's correct. So if we say that this interaction is a force, okay, so it means that, well, explicitly, even the statement here, the expression here doesn't contain a mass, okay? But if we say that this F, the interaction is F, okay, the force, it means that the charge, the charge particle, this capital Q, in this Q here, each of them has a mass, okay? Because this one. So if we say this intensity of accretion is equal mass, it means that we say that the particle have a mass, okay? So there is an implication of this statement. The implication of this statement that the Coulomb's law, implication of the Coulomb's law. Oh, sorry. Implication of Coulomb's law. Each charge particle is massive, okay, but not the other way around. So it means that each charged particle has a mass, but not the other way around. It means that if a particle is massive, then it should not, well, it's not always, it's not always, it has not always, doesn't have always a charge, have a charge, electric charge, okay? So each charged particle is massive, but the other one, it means that the massive particle is not always charged particle, okay? Okay, any question about this? Okay, in general, if you study about the quantum theory in microscopic view, this Coulomb's law is nothing but electromagnetic interaction. We call it this electromagnetic interaction. Electromagnetic interaction is characterized by the charged particle. They somehow exchange so-called the virtual photons. We call it the virtual photons. This gamma. This is a microscopic point of view. Okay. So, but this is in quantum theory. So this discussion, further discussion of this matter is beyond our curriculum. Okay. So we will consider it classically. So using Coulomb's law. Okay. Formally, we could say that, for example, if we take, if we consider Q1 and Q2 are particle with charge Q1 and Q2. You can also say that they have each M1, the mass M1 and M2, just for example. Okay, this we call it R1. R1 is the position of Q1, and R2 is the position of Q2. Okay, and this quantity here is R2 minus R1. Yeah, the difference between the position of Q2 and Q1. Okay, it's also a factor. So formally, we could say that this F21 equals to K Q1 times Q2 over the modulus of the difference between R2 minus R1. Okay. To the 3, the order. Okay. And then we times R2 minus R1. Okay. This subscript, yeah, 2,1, it means that the force X on Q2 goes by Q1. Okay, and the direction of F21 depends on the sign of Q2. Okay, so it means that we could say that Q1 is the source, okay, the source charge, Q2, what we call it in Indonesian, muatan uji kita nyebutnya. Jadi Q1 itu adalah muatan sumber, sedangkan Q2 itu muatan uji. A test charge, ya, sorry. Call it test charge. Okay. This is for example. For example, we have Q1 equals to 1 Coulomb. Okay, and the position of Q1 is 0,2. Okay, and Q2 is minus 2 C, and the position is 2,0. Okay, so in this case, for example, is R1 and R2. Before we discuss about the example, what it means about R1 and R2. So R1 and R2, we could express this vector position, this position vector, in x1i plus y1 g and z1k. Okay. Also R2, we could express it in x2i. This I hat means it's unit vector. Okay. And the unit vector, it means that the magnitude of the vector is equals to 1. Okay. And the magnitude of the R1 vector is equal to the square root of the square of x1 squared plus x2 squared plus x3 squared. And the difference between them, we could simply write that this is a square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay. Is there any question about this before we proceed to the
I want
example?
to ask her.
Yes, yes.
The part when the length of R1 is the square root of x1 squared plus x2 squared plus x3 squared. This is supposed to be x1 plus y1 and z1.
Sorry, can you repeat your question? Sorry. What a moment. Okay, sorry about that. Can you repeat your question?
So the part when it states that the length of R1 equals to square root of x1 squared plus x2 squared and plus x3 squared.
Okay.
Should it be x1, y1, and z1?
Yeah. Okay. Yeah. Thank you. Okay. Yeah. Thank you. Any comments? Any comment? So we could say this length of R2 is basically the same as x2 squared plus y2 squared plus, okay, something like that. Okay, any question? Any comments? Okay, let us proceed to the example we just discussed before. So for example, in this case, so in general, what we have discussed in here, it means that we consider three-dimensional, okay? So three-dimensional, it means that if we take a look at this coordinate system, this y-axis and z and x-axis, the z-axis, is coming directly to your outside the board, okay? So basically, well, you are engineering student, right? This z, for example, this is x, this is y. So if we rotate this coordinate system in three-dimensional, this z here is coming to you, okay? Coming outside the board, okay? This is the convention of this coordinate. We call it right-handed coordinate system. Okay, let us proceed to the example. So we have the example basically for two-dimensional. It means that the z equal to 0. Also in this case, z equal to 0. Okay, only two-dimensional. So if we insert this information, Q1, R1, Q2, and R2, okay, we will have this F21, the force that acts on Q2, okay. This is Q1 is 1 Coulomb, Q2 is -2 Coulomb. okay, and over the length of the difference between R2 and R1 times the difference between R2 and R1, okay, this case, oh, sorry, this one, okay. So we will get, we will have this. This will be I minus J. Sorry, hat. Okay. Okay. So this is the complete factor of F21 minus 36 times 10 to the 9 I hat minus j hat, the factor direction, over square root of 8 to the 3. Okay? And the magnitude of F21, we could say that this is 36 times 10 to the 9 over 8 newtons. So this equals to 9, okay, 4.5. Okay. Okay. Is there any question? Okay. 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 Any question? So if we consider this factor, this R21 is like this, okay? This minus, we have G minus I, okay? R21. Yeah, this is the minus R12. Okay. So basically this, we could also construct the unit factor of R hat 21 is equal to this factor R21 over its magnitude. Okay, the magnitude of this factor is square root 2, okay? So basically this, okay, what is R21? R21, the direction, okay, the direction of R21 is this one. Eh? This is the direction of R. Okay. And the direction of R12 is like this. Hat, R hat. Sorry, maybe this is R1. Okay. Okay, because they have in the same line. Okay, they have in the same line. So it means that we could say that R12 or R21 is minus R12. Okay, and also its unit vector. Is there any question about it? Any question? Okay. Yeah. Okay. Any question? No question. Is it clear? Okay.
Yes, sir.
If you have a test for exam, you should have a full score, yeah, in this case. Okay. Any question? Comments?
Sir, hello.
Yes.
I just want to make sure the R1, the right side, yeah, it's minus I plus j, right? No parentheses like this.
No.
Okay.
No, it's not. Because this one, do we have minus here? Okay. So we put this minus inside, so minus I hat plus j hat. Okay.
Oh, okay, sir.
Okay, yeah, thank you. Okay, I will summarize our lecture today in Bahasa because we have only 7 minutes. Jadi, just a minute. Oke, jadi apa yang kita sudah bahas ya terkait dengan hukum Coulomb. Jadi hukum Coulomb ini merupakan hukum yang fundamental ya di alam. Kenapa? Karena ini bisa dikatakan hukum setelah hukum Newton tentang gerak, yang menggambarkan tentang interaksi listrik. Ya. Jadi kalau hukum Newton tentang gerak itu dia mendefinisikan tentang massa, bahwa sebuah partikel itu dibedakan melalui massanya. Sedangkan hukum Coulomb yaitu ada tambahan lagi. Jadi partikel itu juga dibedakan berdasarkan muatan. Jadi memang muatan listrik dan massa ini apa istilahnya merupakan sifat yang intrinsik ya, sifat intrinsik dari partikel pembentuk alam yang kita sebut building blocks tadi. Jadi ini berlakunya untuk yang sifatnya mikroskopik, yang partikel dasar. Kalau kita aplikasikan ke makroskopik seperti manusia, ya manusia tentunya ada kandungan listriknya, tapi kita tidak pernah menanyakan berapa besar muatan listriknya, nggak pernah gitu ya. Kita pernah tanya juga beratnya berapa, tapi kan itu juga sensitif kan dari beberapa orang. Nah biasanya kalau untuk manusia biasanya dibedakan tadi kata teman Anda DNA dengan sidik jari misalkan ya. Atau misalkan kalau yang lebih kita lihat dibedakannya melalui bentuk muka, warna mata, kemudian warna kulit, warna rambut, terus jenis rambut juga ya, apa dia itu lurus, keriting gitu ya. Keriting juga ada banyak macam-macam gitu ya. Itu yang bisa dipakai gitu ya kalau misalkan Anda mau apply paspor atau apa gitu. Itu biasanya ditanyakan. Dan biasanya difoto gitu kan seperti itu. Nah, jadi dalam mikroskopik case, kasus mikroskopik itu, misalkan contohnya adalah elektron, dia punya muatan minus E, dan proton muatannya plus E, dan juga dia dibedakan dari massanya kan. Massanya itu juga berbeda. Jadi massa elektron itu ordernya 10⁻31, sedangkan massa proton itu minus 27. Oke. Nah, jadi Kemudian interaksi dua partikel ini yang bisa dikatakan Q besar dengan Q kecil. Jadi intinya bahwa hukum Coulomb itu mendefinisikan gaya yang terkait dengan interaksi dua muatan ini. Jadi karena dia itu dikatakan gaya, berarti kalau dalam hukum Newton tentang gerak, gaya itu kan benda tersebut terus punya massa ketika dia istilahnya bisa kita katakan itu sebagai gaya gitu. Jadi istilahnya F ini didefinisikan berasal dari hukum Newton tentang gerak gitu. Jadi karena gaya itu didefinisikan oleh hukum Newton tentang gerak, maka harusnya secara implisit, secara eksplisit ini sudah mengatakan bahwa hukum Coulomb ini bahwa partikel bermuatan itu pasti punya massa. Yang statement ini maksudnya bahwa setiap partikel bermassa setiap partikel bermuatan listrik itu pasti bermassa. Tapi tidak berlaku untuk sebaliknya, partikel bermassa itu belum tentu bermuatan. Ya, contohnya neutron lah ya. Contohnya itu neutron. Neutron dia netral ya, tapi dia punya massa. Jadi tidak bisa arah kebalikan. Nah, statement yang seperti ini merupakan statement yang paling dasar ya. Jadi sejauh yang saya tahu ya, partikel dasar yang ditemukan oleh fisikawan itu selalu memenuhi statement ini. Jadi dia itu bermuatan pasti punya massa. Tapi tidak selalu kalau dia itu bermassa tidak harus bermuatan. Intinya gitu. Jadi itu merupakan statement dasar. Nah, dalam gambaran mikroskopik sebenarnya hukum Coulomb ini merupakan bentuk yang sederhana yang disebut namanya interaksi elektromagnetik. Ya, interaksi elektromagnetik itu dicirikan biasanya adalah benda tersebut, partikel tersebut bermuatan, dan kemudian antar muatan ini mereka saling mempertukarkan yang namanya foton. Kita nyebutnya virtual foton karena fotonnya ini bisa dikatakan di luar bukan gaib istilahnya. Jadi virtual itu yang bukan sebenarnya lah ya. Bukan sebenarnya. Jadi dunianya berbeda dengan yang tempat muatan ini tinggal. Oke. Nah, biasanya kita dalam mendefinisikan hukum Coulomb secara formal itu menggunakan yang disebut namanya ruang Euclid 3 dimensi yang seperti ini. Ya. Jadi ini adalah konvensinya saya ambil ini aturan tangan kanan. Aturan tangan kanan. Jadi aturan tangan kanan itu adalah seperti ini. Ya. Aturan tangan kanan. Jadi kalau saya putar, Y seperti di vertikal, X itu horizontal, sumbu Z-nya itu keluar dari bidang, gitu, seperti itu. Nah, jadi kalau R1 itu merupakan posisi dari Q1, R2 itu merupakan posisi dari Q2, maka kita dapat merumuskan secara formal bahwa gaya antar dua buah muatan itu adalah rumusannya seperti ini. K kali Q1 kali Q2 dibagi dengan besar dari R2 kurang R1 pangkat 3 kali dengan vektornya R2 kurang R1. Besar vektor itu didefinisikan seperti ini. Yang Anda bisa lihat gitu ya. Seperti itu. Oke. Nah, ini jadi contohnya misalkan ya. Jadi saya lupa. Biasanya konvensi F21 itu mengatakan bahwa gaya tersebut bekerja pada Q1 diakibatkan oleh Q1. Jadi gaya bekerja pada Q2 diakibatkan oleh Q1. Jadi bisa saya katakan bahwa Q1 itu sebagai muatan sumber, Q2 itu sebagai muatan uji yang kita sebut namanya test charge. Nah, ini contohnya misalkan saya ambil Q1-nya itu muatan sumbernya itu adalah 1 Coulomb. Muatan ujinya Q2 itu adalah minus 2 Coulomb. Jadi kurang lebih gayanya itu seperti ini. Jadi kalau ditanyakan gaya, Anda cukup menuliskan seperti ini sudah benar. Jadi tidak perlu Anda menghitung besarnya, tidak perlu, dan arahnya nggak perlu. Jadi kalau sudah ditulis seperti ini dalam IJ itu sudah benar. Kalau ditanya gaya, kalau ditanya besar gaya, ya berarti Anda harus tuliskan seperti ini. Kalau ditanya arahnya kemana, nah arahnya Anda tulis seperti ini. Gitu ya. Nah oke, jadi itu kurang lebih